Jump search. Jump search is a searching algorithm designed for sorted arrays. So it works by jumping a fixed number of positions instead of linearly going through all elements in the array. So how it works is, in linear search, it is some kind of walking through the array. In linear search, we had learned that it's walking through the array. It goes through the each element and checks. While jump search, it jumps through the array. It skips a lot of elements, jumps through and finds whether the element is present in that block or not. And in this way, you will be able to reach the elements in quick time compared to linear search. But keep in mind that this jump search technique works only for sorted arrays. Similarly, binary search also works only for sorted arrays, but linear search will work for sorted as well as unsorted arrays. So that is the difference, keep in mind. So let us understand jump search with an example. You have an array, and in this array we'll have a lot of elements, and keep in mind that this should be sorted. So we'll have elements in sorted order 7, 12, 21, 24, 30, 48, 59, 67, 75. Let these be the elements in the array. And what are the indices? 0, 1, 2, 3, 4, 5, 6, 7, 8. So in total, you have 9 elements in the array. The first thing you have to do in jump search is you have to determine the size of the array and the jump size. So here size of the array n is 9. Similarly, you have to determine jump size. How many elements should you jump each time? That is called as m. So generally, it is a convention that you will take m as root n. Whatever be the size of your array, you will take square root of it as the jump size. So keep in mind, it should be an integer. It should not be some point something. So here, because it is 9, square root of 9 is 3. So your jump size is 3. What you'll do now is, you'll take each blocks of 3 as a single part. So you will jump from one block to the next block each time. Whenever you are jumping, you have to make sure whether the element is in that block or not. Whenever you reach the block in which the element is present, you will stop there and do the linear search inside that particular block. So for example, if you are searching for element 67, what will you do? You will start from here. So your jump size is 3, which means you will have block of 3 elements. This is the block that you have first. So you will be in the position 0. You will directly check the last element of this block. Because this is sorted, if the last element of block is lesser than your the target value, that means the element cannot be present in this block. So you'll directly check the last element of the block. If the last element of the block is lesser than the target value, that means the target value cannot be present in the block you are presently considering. So here last element is 21 and it is a sorted array, which means all the elements before this last element of this block should be lesser than 21. 67 is larger than 21, which means you can jump to the next block. So you're already done with the first block. This you have cancelled. You already jumped out of this block. In the second block, you will see the last element. These 3 elements belong to the second block. Last element is 48, which is still lesser than 67, which means 67 cannot be present in this block as well. So you simply eliminated this block. You go to the third block. In third block, what is the last element? 75. And you know 75 is larger than 67. When 75 is larger than 67 and all the elements in the previous block were smaller than 67, you are sure that 67, if present, is present in this block. So you will do a linear search in this block. So in jump search, it reduces the amount of linear search that you want to do. It will jump through, go to the right block and then ask you to do linear search in that particular block. So this is how here you will do linear search. You will see each element and you will identify 67. This is how jump search works. So what we'll do, we'll write the pseudocode and then we'll see time and space complexities of jump search. So let us write the pseudocode. So you should have logic in mind when we are writing the pseudocode, the algorithm. You should have it in mind what all are the steps we have to follow. So we should find the jump size, then we should have a starting and ending position in each block. Then we should be jumping through each block, making sure that the element is not there in the previous block. Okay. So this is jump search. Let us start the pseudocode. Jump search of, you have an array and you have a target. You have to find this target in the array. This is the searching that you want to do. So what all should you initialize? Initially you should have n. What is n? N is the length of array. This is the first thing. Once you have the length of array, next thing is you want to determine jump size. Jump size m. This is root n. We discussed it should be root n. What else should you do? You should have starting and ending position of each block. So initially you will start from the first block. So start will be equal to 0. And what will end be? End is equal to m, because m is your jump size. So m will be your ending position. So these are the initializations you want to do. N is the length of array. M is the jump size, which is root n. Starting position initially it is 0. Ending position of first block is m, because your jump size is m. So at this point you have to define a while loop for jumping. So this is the jumping loop. You will have a while loop. While, what will you do? You have to see, one thing is that you have to see it has not reached the final point of the array. So your end value, start and end belong to the start and end of your present block. So end of the present block should always be lesser than n. If it is n, then you have already jumped through the complete array. So you should make sure you should keep jumping only till the end of your block is lesser than n. And what is the second condition? Your array's last value, the array's last value in the sense block's last value should be lesser than target. Then only you can jump. So basically this while loop is for jumping purpose. You should jump only when the last element in the present block is smaller than your target. So array of end is lesser than target. If these two conditions are satisfied, then what should you do? You should jump. How will you jump? You will update the value of start. Start is equal to end. Whatever was your previous end, that should be your new starting position, because that's the new block. And what should be your end? I'll write here itself. End should be previous end plus m, because m is your jump size. So it should be end plus m. Here you have to make one check. That is, when you are updating end directly like this, end plus m, there is a danger that maybe you will go beyond the array size. So we'll have a check. That is, if this end is greater than n, that is after updation it exceeds n, in that case you should make end is equal to n. So this is a check that you're keeping, so that your updation of end equal to n plus m, that won't go beyond the array size. Once you are done with this, you know this loop will keep executing till you reach a block in which your target element is present, because of this condition. End of target is array of end is less than target. This condition will make it come out of the loop whenever you reach the block in which target element is present. So once you come out of this while loop, you can safely assume that you already reached the block in which target element is present. What is the next step? You have to do linear search inside that block. How will you do it? You again start a loop. This is linear search loop inside that block. So for I is equal to, from where should you start? Start value. So this is the start of the block which is identified as the block with the target element. Start to, till what point should you do? Minimum of end or n. So whichever is the smaller value, the end of the array or the end of the block that you have calculated. So sometimes it may happen that your jump size is 5, but you reach the last block which is having only 2 elements. So maybe the end value would be larger. So in such cases, in order to handle, we put this condition minimum of end or n. If for here you are doing a linear search. How do you do linear search? You have to do if array of I, the array element, if that is equal to target. So this is simple linear search. Then what will you do? You will return the index I, return I. So if this linear search doesn't return anything, that means the element is not present in the array, because you already at this point you already reached the block which can have this element. So if the element is present, it will be present in that block. Then you did a linear search in that block, and if you're still not able to find, that means the element you are searching for is not present in the array at all. So if that is the case, then you want to return -1. So if it is present, it will be returned here. If it is not present, you will return -1 here. Next step is you have to understand what is the time and space complexities of this algorithm. Whenever you see an algorithm, you should be able to understand time and space complexities. First thing is time complexity. In time complexity, there are two phases. One is jump phase, second is linear search phase. So first let us see the time complexity of jump phase. How much time does the jump phase take? In jump phase, you have total of n elements in the array, and each jump size is m, which means you will do total of n by m jumps at max, because each jump size is m and n is the total size of array, which means total jumps at max is n by m. And we already said we'll choose m such that m is equal to root n. So n by root n, which is root n. So in jump phase, you are taking order of root n time in order to complete. And what about the linear search phase? In linear search, you are only doing linear search inside one single block. And what is the size of each block? Root n. So your linear search phase will also take order of root n, because linear search time complexity is order of n. Here the total size of array in which you are doing linear search is root n. So it is order of root n. So jump phase takes root n, linear search phase also takes root n. So total is root n only. Root n plus root n is order of root n. So your total time complexity of this algorithm is order of root n. Jump search takes order of root n time. What about space complexity? This algorithm, as you see, is not taking any extra space other than these small variables which are considered as constant space. Other than that, it is not taking any space. It is an iterative algorithm. So space complexity is order of 1.